This is Greg Troutline with Maritime Reporter TV, and we're very pleased to be joined by Bruce Appelgate, the Associate Director, Scripps Oceanography, to discuss the status and progress of Scripps Institution of Oceanography's hydrogen hybrid coastal class research vessel, CCRV. So, Bruce, as always, I appreciate your time. So, this is going to be a very broad ask to start, but can you kind of walk us through the last 3 years with insights on the highlights, the challenges along the way that progressed the project to this point?
Yeah, sure, you bet. Well, it's been a really fascinating project. The first objective for us was to stand up a project office here, which we did in 2021. And then based on the success of the feasibility studies we've done for a couple of different platforms that used hydrogen as a fuel, we issued an RFI to gauge industry interest in joining us in the design phase of this. So we held took information from the RFI and developed an RFP for design, and then held a competitive bid process to select a naval architect. We did that, and we had a tremendous response and selected Glosten in Seattle as our naval architect, and got them under contract to do the preliminary engineering and design. And in 2023, that culminated in a HAZ-ID workshop that we did with Glosten, but significantly in the interim, they had selected Siemens as their integrator for this project. And we brought on board the American Bureau of Shipping as our class society, and worked very closely with the U.S. Coast Guard, because really the regulatory framework for liquid hydrogen fuel at sea didn't exist. And we are drafting on a couple other cool projects that have been done with compressed gas hydrogen recently, but this really is sort of breaking new ground, and it's a cryogenic fuel. There's an advantage in that hydrogen's been used industrially a long time in the United States, so there's a very strong safety record. The industrial processes and use for hydrogen are very well known. The trick then is in applying that to maritime and doing that with the Coast Guard and ABS, and they've been terrific partners. And that finished in a HAZ-ID in 2023. And after that, we did receive approval in principle from ABS for our design. And December of last year, we achieved preliminary approval under SOLAS from U.S. Coast Guard. So it's a very mature design at this point, and that's really what we wanted in order to take the next step, was to put out a solicitation for shipyards.
I know Morgan Fanberg and the team up at Glosten very well, and I also know that they have a very long, very deep roots in this research vessel community around the world. So, again, I never play favorites, but I've talked to them on multiple occasions. So,
fun fact.
Yep.
This is a novel project that we're working on, really, kind of the first of its kind. Yeah. Glosten was involved in another first of its kind with Scripps Institution of Oceanography in the design of the research platform FLIP, which was one of the very first things that the Glosten naval architecture firm got involved in back in the 60s. And so here we are again. And so it's a lot of fun working with them again.
So with the new vessel, can we discuss the ship specifically? Again, I'm just, I can go onto the website, I can get all the specs, but, just if you can give me an overview of the platform, the size, the shape, the capability that you're looking to build, and specifically detail, not focused in this case on the hydrogen portion of the equation, because we'll get to that, but I'm just looking to dig into what this ship is going to look like and what capabilities it's going to bring to you and your team.
We are an oceanographic institution, and although this is a novel maritime platform, our purpose is to study the oceans. And so my job here is to provide the very best access to the sea for scientists. So that's really job one for us. So fundamentally, no matter what the propulsion of this vessel, it has to be a super capable oceanographic research vessel. And that's what this will be. That was the science mission requirements that we developed. It's the very first part of this job. Looked at everything that research vessels need to do. And then we decided, what do we need to do now, and think about the future? What is a vessel like this going to need in the next 10, 20, 30? Our ships last 40, 45 years. So we want to be ready for that. So fundamentally, we put big, heavy things into the water, and then the hard part is taking them out again and carefully and gently putting them back on deck so that everything comes back okay. This ship will be terrific for that. It's going to have overboard handling systems that will allow us to deploy all the instruments we need. It will also be outfitted with our current ship that's this class is the Robert Gordon Sproul. It's a 125-foot vessel. It does not have DP. It's got a couple of fixed pitched propellers. And we have a very skilled crew on board who's able to keep it on station, but that's not the same as having DP. So the new ship will be a dynamic position vessel, have a bow thruster and azimuthing stern thrusters, L drives in this case. So it's going to be a remarkably maneuverable ship. And we like to say we don't go fast, but we go very precise in oceanographic research. And this will be able to do stations where we'll need to stay in one spot and lower CTD rosettes down to the bottom, and that takes hours, and you got to stay within a couple of meters watch circle while you're doing that. So this will be able to do that, and it's going to have terrific mapping sonars, mid-water imaging sonars, sub-bottom profilers, an atmospheric meteorology suite. So sampling everything from the top of the atmosphere to the inside of the Earth. That's what our ships do, and this will be a very modern, very capable ship with lab space on board. It's something like more than double the lab space of our existing ship, and more than double the deck space as well. So the existing vessel is 125 feet long. We made this one about 10 meters longer for a special reason. It was intended to be a replacing kind, but if you're intrigued, I can tell you about that extra 10 meters.
Absolutely. Oh, I'm very intrigued. So what exactly is in that extra 10 meters?
So I'm moving away from the scientific capabilities, and it has to do again with propulsion. But the idea with this hybrid vessel is we feel it's a very good approach for taking on this novel new fuel in a way that still enables us to have the confidence of a well-established fuel system. So the alternate fuel to liquid hydrogen on the ship is going to be diesel fuel marine. So we're going to have diesel generators that'll make the electricity that will run the plant when we're not using the liquid hydrogen. Long term, we would like to move away from diesel fuel and look at methanol as a fuel. And there's a couple of reasons here in California for doing that, in that the regulatory environment here in California is looking at lower and lower emission ways to operate offshore. And methanol offers a pathway. And we have the ability to demonstrate that in a way that some commercial operators may not. So our goal is to, once we've got the ship on the water and established, have our feet under ourselves, we're looking at potentially repowering to having the alternate fuel be methanol, say 5 years after we're operational. And to do that, since the energy density of methanol is about half a diesel, to keep our range the same, which is an important requirement for us, we needed to have about twice the tankage. So to do that, we just lengthened the ship long enough to put methanol tanks. So we're future-proofing the ship that way. It also made our scientists very happy because now they got much bigger deck space to work on.
Obviously, as you know, I mean, from a shipbuilding perspective, to be able to think in advance and plan in advance, because it's much cheaper and much more efficient to do it at the design phase than it is 5 years afterwards and say, hey, let's throw in, methanol or the methanol tank. So I know that very well. Let's kind of talk about the from my mind, the showstopper of the project, which is the hydrogen hybrid propulsion. Again, because it's interesting for me because we talk about fuel transition and maritime relentlessly, but it still is relatively novel. So can you discuss the details, the technical specification from the power plant and key suppliers with insights again on why hydrogen was seen at the outset as the best fuel for this specific ship?
Sure. So we're in California, and California has a very robust hydrogen economy already. For more than a decade, the state has been building its hydrogen infrastructure here, and it's used across the economy already. You can buy a hydrogen-powered car, you can fill it up at a hydrogen fuel station in parts of California. So that's something that exists within California. So from that part of the infrastructure side, this is something that we've checked into, and we can get the hydrogen we need when we need it from a variety of vendors here. So California is a great place to be looking at something like hydrogen. Now there's environmental benefits to hydrogen. Clearly, it's a zero emissions fuel when you run it through fuel cells at the point of use. Hydrogen is useful not just for its environmental aspect, but it's also useful because of the scientific benefits that it provides. So just like driving an electric car, it's very quiet. So without even trying, we can meet ICE's underwater radiated noise curves without doing anything special to this vessel when it's running hydrogen. The hydrogen goes through a fuel cell, turn that to electricity, and it turns propellers. And if we do our job right, they won't cavitate at the speeds that we'll be using. So it'll be whisper quiet, this vessel, which is important to us because so much of what we do involves acoustics under the water. And the way you get better acoustics is you improve your signal to noise. Well, you can either do that by pumping out more volume, which maybe that's okay, maybe it's not. But an easy way to do it is be able to listen better by having a quiet platform. So we're going to increase our signal to noise by having a remarkably quiet platform that will enable lots of terrific acoustic research that we'll do. So that's an important reason for moving towards hydrogen. Geographically, where we are, the scientific benefits, and also it's a zero emission system, so you don't have to suck stat gas when you're working on the back deck, which is nice, right? The system itself, we've got a liquid hydrogen fuel tank, so it's a cryogenic fuel. So this is it's a big lozenge-shaped tank that is going to sit up on the L1 level. So it will be exposed to weather, and it'll hold enough hydrogen that will power the vessel, completely power the vessel for more than 2 days operationally. So it turns out that 75% of our missions are less than that in duration and range. So we're going to be able to conduct 75% of our missions entirely on liquid hydrogen. So that's in terms of our science mission requirements, what we needed this vessel to do was to be able to go at least that long without refueling. So that made it attractive for us as well. Hydrogen, even though it's new in the maritime arena, it is a well-known fuel, and there are power systems that are known to work. We've had buses in California that run on fuel cells for a long time. So its technical readiness level is where it needed to be to take the next step to integrate aboard a ship. So for lots of reasons, hydrogen was kind of an obvious choice for us.
Looking specifically again at the hydrogen hybrid propulsion system, what do you see as some of the challenges, I guess, to bringing this to life? And again, I'll take this all the way from the training and education of your personnel on board the ship. And again, you kind of already covered it. You said California has a robust hydrogen economy already, so that perhaps dispels that chicken and egg where you're going to get the fuel concept. But when you look at it holistically, what challenges do you see?
Right. So a huge challenge that we've had, of course, is the regulatory framework and the fact that it just simply didn't exist. And we've sort of ridden the crest of the wave of some of the efforts that have gone on here in the United States about starting to develop frameworks for these alternative propulsion systems. So that we've put in significant effort working with the American Bureau of Shipping as well as U.S. Coast Guard to identify where the safety issues were and then mitigate the risks. So that's been a huge challenge for us. I think whoever follows us down this path will have a much easier road to follow because we've blazed a lot of this path. We're not completely there yet. We've still got to do design, detailed design, and there's the operational aspects of how we're going to operate this ship that we still need to explore. with ABS and the Coast Guard. So we've got a HAZOP workshop that we'll need to fulfill. So those are significant challenges because we want the ship to be as safe as any other shipping in the United States. And we're confident that we can get there. We got a terrific engineering team, but we're paying attention to all the safety issues that we need to make this a really good vessel. That's been a huge challenge. Putting a good team together is always a challenge. I think we've done a great job. Glosten's pulled together a great team there, and with our integrators at Siemens. I'm very confident that we got a really terrific team working towards this. I'll say that we've done a fair bit of due diligence looking at what systems do exist that sort of put our minds at ease that this is something that's doable. We visited the Hydra, which is a liquid hydrogen powered ferry that's operating in Norway, and we rode that back and forth across the fjord all day. And what struck us talking to the chief engineer on board and the captain and the 1AB that was working on board was that it was just so routine. It was as routine as any other ship you would expect. And the other thing that struck us, of course, was how quiet it was. It was just absolutely quiet above deck, and then down in the machinery spaces too. We had a conversation like this in the engine room.
I know there are many partners involved in this project. You've already rattled off a few: ABS, Glosten, Siemens, obviously. And it's I don't want to make it like an award show where you thank everybody, but when you look holistically at the project, are there beyond the three that we've discussed, are there more that really contributed to where you've started to where you are today?
Well, we're in the detailed design phase. So some of the elements of the design that still need to be worked out include the got system. So taking the liquid hydrogen, vaporizing it, and then getting it down into the fuel cells at the pressure that you need. So we've got Chart Industries on contract now. They're providing the cryogenic fuel tank and the gas system, and they'll be working on that for us. And we've selected Ballard fuel cells, and the propulsion, it's a 1.2 megawatt system. So we've got 6 stacks of 200 kilowatt fuel cells, and so they'll take the liquid hydrogen, vaporize it, send it down there, and turn that hydrogen into electricity and water, a little bit of heat. And another fun fact, we'll use the pure water that comes out of it in our scientific labs because our biologists need ultra pure water. And on a normal research vessel, you take seawater and you put that through a distiller process, and then that goes through an ultra purification system to make the water. Well, we can just turn the spigot on this system and it comes right out. So it's a fun use of the wastewater that comes out of this thing.
No, absolutely. Using every resource possible. So, Bruce, I truly appreciate your time. It's always a pleasure to catch up. I just have one more question. I know the RFP was just sent out, but can you give me guidance if you've had any good response? And, long term, what's the projected timeline to when this vessel will be delivered?
Yeah, so the response that we've gotten to the RFP has been terrific. We're looking forward to evaluating all the proposals that do come in. And I think it's a 90-day response time that we've got for the RFP. And then we've carved out a couple of months for the review of that and hope to get somebody under contract very shortly after that. And then once we've got a shipyard under contract, we have a period of detailed design that we're going to go through. And figure that's probably going to require another 9 to 12 months to get that out of the way, and then cut steel and as expeditiously as we can get this thing assembled. And if that's a 2-year process, that'd be terrific. So following delivery, we've got we're going to carve out 6 to 12 months to demonstrate the propulsion systems, but the other added element for us as a research vessel is we've got to demonstrate all the science systems on board too. So So we'll do the ship first, and then we've got a period of burn-in for making sure all the science systems work correctly. So hopefully within a year of taking delivery of this thing, we'll be able to enter it into productive service as part of the U.S. academic research fleet. So that's our hope.